I've been thinking about this lately. Beat. Everyone is just completely obsessed right now. We are all mesmerized by raw reasoning power.
Oh,
We watch these massive new frontier models. Like GPT 5.6 is constantly dominating the news cycle. Claude Opus 5 is pushing logical boundaries. And Gemini 3.6 Flash handles complex queries instantly.
right. And they are genuinely incredibly impressive. But, while everyone stares at those text-based models, a totally different revolution is happening quietly.
Yeah.
I mean, we are seeing something entirely new emerge. We are witnessing the rise of AI game builders.
Welcome to this deep dive. We are thrilled to have you with us today. Our mission here is simple but deeply fascinating. We are looking at a rigorous new test. It compares three distinct AI game builders. We are analyzing Base 44, Replit, and Lovable.
Yeah, we want to answer a very fundamental question. Can you actually turn simple text prompts into playable games? Or do these tools just spit out pretty unplayable screenshots? That is the exact question we need to answer. So we are putting these three platforms through an absolute gauntlet.
We really are. We are pushing their technical limits. The test uses three very different game projects. First, we test them with a multiplayer board game. Then we move on to a 2D platformer. Finally, we push them with a 3D first-person shooter.
Exactly. Each prompt covers a completely different level of game creation. It seems like a brilliant way to evaluate them. We get to see how each platform handles basic gameplay logic. We see how they handle real-time physics. And we see how they manage complex spatial environments.
Right. We are going to look closely at their actual performance. We're not just judging these generated games by their surface appearance. So if you are sitting at home right now, you might be wondering how an AI actually builds a game. Let's start with the absolute foundation.
We have to. Before we test real-time physics or graphics, we need to know something very basic. Can the AI handle fundamental rules? Can it manage turn-based logic and state management? This first test checks if the AI can connect basic systems.
It needs to link player turns, movement, and scoring. The prompt asked for a browser-based 3D party board game. It needed to support 2 to 4 local players. It required exactly 30 connected spaces on the board.
Yeah, and we needed dice rolls ranging from 1 to 6. It also asked for special reward and penalty spaces. Plus, it needed a system for active score tracking. It had to remember every single player's current status.
Only one player can act at a single time. The game must switch automatically to the next player. The win condition triggers when someone passes space 30.
Right. Every single dice roll had to move the correct token. It had to move by the exact number of spaces. Scores and special spaces had to work without manual fixes.
Managing a game state is incredibly delicate. Beat. Think of game state like stacking Lego blocks of data. The AI doesn't just look at the finished tower, it has to remember exactly which block supports which.
Yeah, it's super fragile. If it forgets that player 3 was panelized on turn 2, it is like pulling a foundational block straight out. The visual graphics might still look perfectly fine, but the underlying data structure just completely collapses.
The logic just falls apart.
Right.
So Base 44 generated its game in about 5 minutes. It was the absolute winner in this first test. It connected the user interface and the gameplay perfectly.
It really did. You could roll, move tokens, and switch turns seamlessly. It even triggered a trap that removed 2 points from a player. And it did all this without needing a single manual code fix.
That is honestly remarkable. Now, we also looked at Replit and Lovable. They both produced polished, colorful 3D boards and clear setup screens. But there was a major catch with both platforms.
Oh, definitely. You had to do a full match playthrough to confirm anything.
Yeah.
We needed to see if the internal logic actually held up. You can't just assume they work based on aesthetics alone.
You really can't. So why is it that an AI can generate a beautiful 3D board but might fail at simply switching turns?
Well, that comes down to how these models process different tasks. Rendering graphics is essentially a form of visual pattern matching. But managing a game state requires strict sequential logic and memory. Language models sometimes just lose track of that exact sequence.
So calculating rules is much trickier than just drawing a pretty board.
Precisely. It is a completely different cognitive muscle for the model. Writing sequential logic requires strict mathematical discipline. Since Base 44 proved AI can handle turn-based logic, let's look at the next phase.
Right, let's see what happens when we introduce real-time physics. This is where the player has constant control. The prompt asked for a 2D pixel art platformer. It required movement, normal and double jumps, 3 enemies, coins, and 3 health points.
The main focus here is on collision and level progression. Base 44 took about 4 minutes to build its version. It delivered a simple but very clear level layout. It had all the requested gameplay elements in place.
It really did. I have to admit something here. I still wrestle with prompt drift myself. So seeing an AI make a character jump feels like magic.
It really feels magical when it finally works. Lovable took about 7 minutes to build its game. It was a highly polished experience. It had consistent pixel art for the character, enemies, and even moving saw obstacles.
It looks fantastic. Then we have Replit's attempt. It took about 8 minutes and had a good pixel art style, but it completely failed the physics test. It suffered from major collision detection problems.
Yeah, it was rough. Players would just fall straight through the solid platforms, or they would get permanently stuck on the edges. It made the jumping mechanics entirely unreliable.
Why did Replit struggle so much with collision detection when the visuals looked fine?
Because drawing a platform and defining its mathematical boundaries are two separate tasks. In game engines, the visible pixels are just digital wallpaper. The AI often forgets to align the visual sprite with the invisible physics hitbox.
Right, making things look solid doesn't automatically make them act solid.
Exactly. Physics requires flawless invisible math, not just pretty visible pixels. The model has to coordinate both layers perfectly.
Insert provided sponsor read here.
Welcome back. So we've seen AI struggle with 2D hitboxes.
We really have. The invisible math got incredibly sloppy. So what happens when we add an entire z-axis? What happens when we demand a fully interactive 3D combat loop?
This was the ultimate stress test. The prompt demanded a browser-based 3D first-person shooter. It specifically required using Three.js for the rendering engine.
For those unfamiliar, Three.js is a tool for creating 3D graphics in a web browser.
Spot on. The requirements here were quite demanding. It needed wave keyboard movement and smooth mouse aiming. We asked for active shooting, ammo tracking, and moving enemies.
Base 44 completely buckled under this level of complexity. It loaded a user interface with health and score, but the actual gun and the 3D map were entirely missing.
It just gave up. Replit took about 11 minutes. It actually managed to build a playable 3D environment with a gun and enemies. But the lighting was extremely dark, making navigation very frustrating.
It felt like walking through a pitch-black maze. Then we looked at Lovable. Lovable absolutely knocked it out of the park here. It delivered a bright, clear arena-style map.
Yeah, it was stunning. It had a clearly visible gun and actively moving enemies. The ammo tracking was perfectly clear and highly accurate.
Whoa. 2-sec silence. Imagine generating an entire interactive 3D arena from text in minutes.
It is a massive leap forward. It shows the true, staggering potential of these AI builders.
But when Base 44 just gave up on the 3D graphics entirely, what does that tell us about the limits of current AI builders?
Well, 3D spatial generation requires massive context windows and complex math. When the AI gets overwhelmed by this data, it panics. It essentially prioritizes the UI text over rendering the geometry.
Yeah, generating a full 3D world pushes these models to their absolute limit.
It really does. Let's synthesize the results of these 3 rigorous tests. We want to give you a practical takeaway on which tool is best.
It depends on what you need. Base 44 is clearly best for creating games with strict, clear gameplay logic. It absolutely crushed the board game test, but it fails at complex 3D projects.
Right. Replit feels like the true hacker's choice. It is great for building flexible prototypes, but that assumes you know how to fix lighting or collision bugs yourself.
And Lovable is undoubtedly the best overall choice right now. It offers the greatest balance of gameplay, visuals, and presentation.
Exactly. But there is a big idea here. Never judge an AI-generated game by a simple screenshot. A highly polished screen can easily hide a broken collision system. It could obscure missing mechanics or incomplete win conditions. You have to play it from start to finish.
That is such a vital point to remember. It makes you think deeply about the near future. If AI can now build complete 3D environments from a single prompt, how long until games are generated in real time while we play them?
Wow, yeah.
Imagine a game reacting uniquely to every single choice we make, constantly generating new levels, characters, and physics systems entirely on the fly.
That is the next great frontier in digital entertainment. We were watching the very first steps of that evolution today.
Think about what kind of entirely new game you would prompt into existence today. Thank you for joining us on this deep dive.